আমি go live করে দিই। হুম, আরে টেনশন নেই না, বিন্দাস আরামসে করবেন, হ্যাঁ, আস্তে আস্তে। আস্তে আস্তে। ফিল করে ফিল। আস্তে আস্তে। Oh my god, আচ্ছা। ফিল করে ফিল। আমি শুনো। হ্যাপি। হ্যালো। আস্তে আস্তে। Oh my god, আচ্ছা। ফিল করে ফিল। আমি শুনো। হ্যাপি। আস্তে আস্তে। Oh my god, আচ্ছা। ফিল করে ফিল। আমি শুনো। হ্যাপি। আস্তে আস্তে। Oh my god, আচ্ছা। হ্যালো। Yeah. Yeah, that regarding that actually, I think you have prepared for the interview, right? Means you have prepared for the interview. Hello, can you hear me? Yeah, means, like in the interview you was present. No, 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 no. The interview has already been held. Like I think, so like already selection procedure is over. I forgot the date actually. I think it's the last week only. I think. So we have not got any like mail regarding the interview and all.
Hello everyone. So good evening. I hope I am audible and my screen is visible as well.
Yeah.
Okay, thank you, sir. So good evening everyone present here. On behalf of the IEEE Computer Society Student Branch Chapter, I welcome Mr. Nagaraju in Kodalapura, Principal in Engineer in Offensive Security Research at Intel Product Assurance and Security Intel Corporate. He will deliver his talk on confidential computing, Intel's approach and technology offerings. I am Vedia Shah, the Vice Chair of IEEE SBC. I am also a PhD scholar in the Department of Computer Science and Engineering in Kharagpur, and I am pursuing my PhD under the supervision of Professor Shudip Mishra. And I am going to be the host of today's event. So, before we begin our talk, I would like to introduce our esteemed speaker to our audience. So, Mr. Raju, he received his MS degree in digital design and embedded system from Manipal University, India. He has five granted Intel patents and he is an IEEE senior member with 5 plus security research publication in IEEE, Black Hat and other renowned venues. He has 20 plus years of experience in the semiconductor industry, mainly in Intel Corporation. He has been working in the security research space for more than 15 years. In his tenure at Intel, Raju has received in various India, Malaysia, and USA and is currently based in Bangalore, India. He leads a team of offensive security research focusing on confidential computing and virtualization technologies. So there are some general instructions for all the audiences. So I request you all to please keep yourself muted during the talk. Please wait till the end of the talk to ask any question. There will be a Q&A session at the end and an attendance sheet will be distributed at the later point of the talk. Please make sure that you note your attendance there. You may type any question, issues you are facing in the chat box. And finally, we will be taking a group screenshot of the event. So I request you all to please turn your camera, if possible, when you will be asked to. So with this, we would again like to welcome Mr. Raju to deliver the talk at our event. Thank you for your time and over to you, sir.
Thank you so much for the brief introduction. Let me get started. Let me share my screen and let me know if you all can see it. Can you all see my screen?
Not yet, sir.
I see. Still not coming?
No, sir, not yet. I have stopped sharing
Oh,
my
it
screen.
says, I see. It says sorry, an error has occurred when screen sharing. Let me do it again.
Okay.
Okay, maybe I'll try entire screen. Let me know if you can see. Okay.
Sure. Okay.
No, it still says an error has occurred. Screen sharing. I don't know what is going on. Can you see
You
screen? My
can.
screen?
No, sir, no, sir. You can just disconnect and try to reconnect once again. Will it?
I see. Okay, I will log in back.
अब तो देख रहा है पूरा लोग पूरा संसार स्माइल प्लीज
Yeah, I am back now. Let me try to share my screen again. Oh, something weird. I'm getting an error message saying that error has occurred when screen sharing.
Can you just check from some other web browser if possible?
Possible. Yeah, let me try from Chrome.
otherwise you can
Yeah, I will leave for
ask
a quick.
slides you will present and we'll get to last option होगा है Why they happen? On your camera lagaओ.
Can you hear me now?
Yes, sir. Yes, sir. You are audible.
Okay, let me try to see. Let me know if you can see my screen now. Can you see now?
Yes, sir. Yes, sir. It's coming.
Great. Okay. Hey
Yes, sir.
everyone. Good evening. Thanks for joining. Let us get started. So, yeah, as I am Nagaraju Kodalapura, Raju, no principal engineer at Intel. Today we are going to talk about confidential computing and what is Intel's approach and some of the technology offering in this space. So, as per the agenda, I think I was asked to provide a talk for close to 90 minutes, and this is the way I have split that subtopics. First, we will spend time on what is confidential computing and brief introduction to it, and see how it plays a key role in offering cloud security. And then we will learn about what is trusted execution environment or TEE, and followed by some of Intel's technology
Uh,
offering in this
Excuse me,
space.
Raju.
Yeah.
Sorry to interrupt. In case you are sharing the PPT in the slide mode, it is
Mhm.
not. It is not in that mode actually.
Oh, really?
It's still showing the
Oh,
normal PPT view, and it is in the first slide.
I see. How about now? Is it moving?
Uh, no, it's still in the normal mode. It's not in the presentation mode.
Correct, but at least is it
Yeah,
progressing?
yeah. The yes, yes. Progress we can see. We
Okay.
can see the different slides.
Okay, not sure what is going on because maybe I will try once again to go to presentation mode and let me know if you guys can see. Can you see my slide 3 or it is in slide 2?
Still, it's in slide two notices and disclaimers.
Okay. Yeah, it looks like
Now it's come
some.
to agenda slide. Okay.
Yeah, and maybe what I will do, right? Let us not spend time on all those problems. Let us focus on the presentation.
Sure.
I hope this is no still is visible, right? You can see my screen. Maybe I will just. I will not go to the presentation mode then.
Yeah, it's visible.
Okay. So as part of the agenda, no, first we will understand what is confidential computing and its role in secure cloud computing. And then we will learn something briefly about what is trusted execution environment or TEE and how that can be applied to realize confidential computing. And then we will learn some of the key technology offerings from Intel to fulfill the confidential computing objectives. That will be the primary focus of this presentation and followed by Q&A. So I have some questions. I have all like a quiz at the end. But during the course of presentation, I know there was a guideline to ask questions at the end. Maybe you can make a note of those questions, maybe to a particular topic, and we can come back and discuss it. And one major objective of this presentation, right, as you are all focusing on as your regular curriculum, security is definitely one of the key topics in the industry. And my intention is to bring that awareness why security is important and what kind of mindset one requires to really establish a secure computing, both from developing security technologies versus how to break from a hacker's mindset. Because they are always playing hand to hand, and we need to make sure that based on our interests and skills. Both areas are equally important in the industry. And I come from a offensive security research background where my focus is mostly on to evaluate and try to break the security claims and eventually help strengthen those security claims at Intel. So I would like to acknowledge my offensive security research team and the management and also Intel's lead program committee. And I would like to acknowledge Professor Rajat, who used to work with me in Intel and now he is a professor in IIT Kharagpur. So I would like to acknowledge him. And I would like to also acknowledge IEEE CSSPC and for organizing this, and also the Confidential Computing Consortium, where I am a member of Technical Advisory Committee. So, to understand and appreciate confidential computing, maybe we need to understand why even we need it, right? Because you may keep hearing, especially in the industry, we keep saying the data is the new oil, which means the data protection is at has a very high requirement compared to any years earlier. And of course, data protection is not something new we are talking now because it exists for decades when the computation started. And in order to understand confidential computing, maybe I will give you some quick background. What are the conventional data protection schemes we have? The first one is the data protection at rest. As we all know, in order to protect the data when it is at rest, we mean something like a storage media. We have some techniques like encrypting the inactive data when stored in the form of blob and also in database, etc. And we have technologies like Azure Storage Service encryption for data at rest, and even from Oracle, we have SQL Server TDE. These are some technologies available to help protect data at rest. And data in transit, I'm sure you all know about network security in general, especially with the emergence of internet, the protection of data while it is in transition, especially from a public to private or private to public, becomes very essential. And also on top of it, when we say public network, most of the time it could be untrusted, and a private network mostly requires some security. So that's why it's very, very important to make sure that we protect the data when it is in transit. And that is also accomplished with the help of well established protocols like HTTP Secure and TLS and so on. So, this is how we also manage to accomplish data protection while in transit. What is the emerging usage and what is known as confidential computing? It's about protecting the data while it is in use. That is what we mean by confidential computing. That means protect or encrypt the data that is used when it is under computation within your physical memory or DRAM. That is what is confidential computing means. And how do we accomplish is with the help of two well-known solutions. And first of and foremost of that is TEE or Trusted Execution Environment, which is basically a technique to offer confidential computing to protect the data while it is in use. And the second technique is homomorphic encryption, which is still a emerging or evolving technology to offer confidential computing, where the data is always encrypted and it all the entire computation happens on the ciphertext. So that is very expensive, at least for the current generation of products, and maybe in future that may also become a mainstream technique to enable confidential computing. And in today's discussion, we are going to focus on trusted execution environment and see how that will indeed yield to offer confidential computing. From a business standpoint, confidential computing is the next frontier in data security, and it is expected to grow to up to 54 billion US dollars market by 2026. And companies like Intel are betting big, and even the cloud service providers, they also relying upon confidential computing to offer a lot more security-centric services. So maybe I will share this slide deck after the presentation, and this is emerging, no, one of the forum, we have something called Confidential Computing Consortium, where major companies are participating in this consortium to bring the like-mindedness to offer a one objective, that is to bring together hardware vendors, cloud providers, and software developers to accelerate the adoption of trusted execution environment technologies and standards, because every company or CSP may want to deploy their own way of confidential computing, then it becomes a scalability problem. Whereas with confidential computing, all the companies are coming together to see how there can be a interoperability between different vendors and software developers and the CSPs to make the end user life more easier. So that is the primary objective of confidential computing consortium.
Oh, I guess.
In the prior art, as we discussed earlier, data is often encrypted at rest or in transit, but not while in the memory. That is one of the limitations to really offer data protection while it is in use. And confidential computing helps to protect data in use by performing computation in hardware based TEEs. That is the primary motivation. And we will see what type of technologies that Intel offers based on the hardware based TEEs to eventually fulfill the confidential computing objectives.
For sure, for sure.
And also, you may be wondering why confidential computing is important. It's primarily because of the emerging cloud usages, right? Because your data is residing somewhere in some server sitting somewhere in the corner of the world. And now you want to run your workload in a secure way, or you want to run some secure workload directly. And how do you establish a trust in such remotely executing data center server to believe as if it's your own machine? So that is a challenge, and confidential computing is primarily trying to answer that question so that end user will be able to peacefully run the secure workload in a cloud environment.
Okay.
And I have given links to a lot of webinars like this on confidential computing coming from this forum. And if you are interested, please take a look at those trainings as well.
Okay, correct.
So, in order to understand confidential computing implementation, we have to understand TEE or trusted execution environment much better. So, the keyword trust. I love this book, the word where we say, in God we trust, all others bring data. That means an entity can be trusted if it always behaves in the expected manner for the intended purpose. And that is not a simple claim, especially when you are trying to build a secure environment in a general purpose computational platform. For example, companies like Intel will build general purpose CPUs, right? They are meant for general purpose usage. And now the intent is to also offer some security technologies or features so that end user can get benefited. But how do we do that? It is not simple, though we want to make it simple. So there are certain security properties that a TEE should fulfill in order for it to be adopted for usages like confidential computing. So what are those three major usages or properties? So the very first one, a TEE application or a secure application where you want to include some security sensitive data, that type of application should be able to isolate itself from the rest of the system in a host environment. For example, if you have an operating system and you have running hundreds of applications, and there you have a secure application that you want to execute, that application should be able to protect and isolate itself from the rest of the system. However, a application running in isolation will not be useful unless it has some well-defined interfaces to talk to the external world. That's why the very first security property of a TE application is to have some well-defined interfaces using which it should be able to talk to the host environment and exchange data, command, or whatever. And this interface could be software based or hardware based. And from a hardware TE perspective, we are mostly focusing on the hardware interface. The second important property of TAE is it is not just sufficient to talk to the host environment and carry out some activity, but it also should be able to securely do some transactions with peripheral devices. Right? That is the only time that application will really become useful to the real usage. And such interfaces could be trusted input output, trusted storage, secure networking, etc. The TE application should be able to basically use such devices in a secure manner, though they are all sitting on a general purpose computing platform. And that is the second property of a TEE. And the third and most important property is called attestation. Attestation is nothing but the process of identifying the legitimacy of a TEE platform. What I mean is, let us say if you all want to run your DE application in some server on AWS, for example, you want to know what are the properties of the CPU ID and what is the firmware security version number, what are the different firmware components that are running on that platform, whether I can trust those components, they are coming from legitimate source or not, right? We will have lots of questions from an end user standpoint. How do I build the trust to an end user saying that the platform on which you are running your workload indeed is a trustworthy platform? And that is accomplished with the help of attestation flow, where a remote server, which is typically a registration server, which who will be able to provide attestation service by means of basically the attestation server or a registration server will have a blueprint, let us say, as a reference copy to say which platform properties I would trust if this platform is reporting. So what happens is during the process of attestation, the DE application will get the information on the platform about all the firmware components, hardware components that are existing on the system, and it will send a report, cryptographic report to the backend server, and that backend server will be able to do a comparison analysis of the report that was generated by this TE app on the target platform and the report it has, which is also supplied by the platform owner to measure and verify them cryptographically that this is coming from a legitimate CSP or service provider. Once it verifies, then it will let the TE application know that yeah, your platform properties are looking to be secure. Now we are good to go and start using the platform. Only at that point, the TE application will be ready to process some security centric data. Until that point, we don't encourage and we don't even say that TE application is secure. So, in a nutshell, TEE is nothing but a secure area which is able to protect itself from software attacks originating from the host environment and from hardware attacks that is external to silicon, which means that a TEE, that is why we call it hardware TEE, which is basically housed inside of the CPU, and it is a pure hardware root of trust based environment. And it is also able to protect from some hardware attacks that can originate from peripheral devices or through network, accelerators, and so on. And it can also protect itself from software based attack that can originate from the host environment. So, in the coming up technology examples I am going to share, you can give attention to see how each of the technology I am going to talk about is trying to fulfill these objectives and eventually they can form a DEE and contribute to confidential computing. So, in this slide, I am going to provide a quick, high-level summary of technologies that are offered by Intel for confidential computing. And then we will go a little more deeper into the high level security objectives and threat model associated with those technologies. So if you see this bar from left to right, you see that on the left hand side we see deployment simplicity, on the right hand side we see data isolation. That means in order to offer a security centric technology, what is most important is the data isolation. The better data isolation your technology can offer, more securities. Whereas from a deployment standpoint, another challenge is it will be maybe very challenging to deploy a very high data isolation capable solution because it comes with lot of overheads and complexity. So in keeping those two parameters in mind, Intel has devised three major verticals of technologies. The first one is called Intel's Total Memory Encryption or TME. Why TME is important and what security objective it is going to fulfill and how the architecture looks like. I'm going to cover each of these three verticals in coming slides. But here, what I want to emphasize is that total memory encryption is basically a technology which is devised to protect from something called cold boot attacks, or let us say maybe 10, 15 years ago, if we have seen or used the computer or phone, whatever, typically the physical memory or the DRAM in those devices, they were all not encrypted. That means if you want to run some secure application or even your own Windows login password credentials, they were sitting in the DRAM in clear. Suppose if an attacker gets access to such a device and dumps the DRAM, he or she will be able to get the DRAM content in clear and he can even get access to the password, login details, and so on. That is what is called cold boot attack. And to prevent such attacks from happening, the first technology we offered is called total memory encryption, where the entire DRAM is encrypted
I see.
with one key,
Well, that
and that hard key is also rooted in the hardware.
I did.
That way, attacker will not be able to get access to the key easily. And we made the hardware encryption as part of the hardware architecture so that the encryption decryption also becomes faster and it becomes really performance friendly. And today, if you look in any of your phones or laptops, etc., you hardly find any phone without an encryption capability, or a laptop, or a PC, or whatever, because it has become almost ubiquitous, where by default everybody is enabling encryption and we don't see any performance implications due to the advancement in the technology and usage. And this is called total memory encryption. But one thing I want to emphasize and you guys want to give attention to is this color coding. Right? I have two boxes. One is the orange, the other one is the red. The orange no lines box indicates that what are we trying to protect against using this technology is nothing but the DRAM. The entire DRAM is under protection with TME. And what is trust boundary? Trust boundary is nothing but a property of a security feature or a technology which will identify which are the entities I can trust and which entities I cannot trust. That is what will define your trust boundary, or in true terminology, we say TCP or trusted computing base. And when you look at TME, in order to protect the DRAM, we have one encryption key, and that encryption key is mostly programmed by the hypervisor. But the same encryption key is used by all the application and the guest OS or whatever the system software you have. They are all encrypted with one single key. That means even if one application is compromised or an attacker get access to, and eventually if we get holds of the key, that entire platform or the system will be compromised because the entire software stack running on the platform is encrypted with one single key. So, in order to offer security of such a technology, we have to trust all these components, which is quite huge. And that is one of the primary requirements of TME. Now, let us move towards the extreme on the right side. So, here, what we want to do is, I want to if you're familiar with Intel architecture, we have this concept of ring 0 and ring 3. Ring 0 is basically a CPU mode typically used by drivers and kernel, which has a higher privilege and it has access to the hardware resources. Whereas ring 3 mode of CPU is mainly meant for applications that are running with less privilege, and they are also managed by the ring 0 drivers or operating system. So, but with SGX, what we want to do is we want to isolate this ring 3 application from rest of the system. That means I don't want to trust any of the high privilege software like hypervisor or guest OS or normal OS in which my application is executing. And I also want to trust only a portion of the hardware that is provided by Intel SGX architecture, and even rest of the software or hardware component running on such a system is malicious or gets attacked by a hacker. My application should be able to protect itself. That is the motivation of SGX, and I'm going to talk more detail on SGX in coming slides. But the key message here is that if you see the amount of number of entities that we want to trust to enable SGX is very minimal. It's just a ring 3 application and a portion of the hardware, whereas the rest of the system can be untrusted. The middle portion is also equally important and interesting from a security standpoint, because in the emerging cloud usage, we have something very unique, that I want to run my secure workload in a data center, and that workload can be a guest OS itself or a virtual machine. If you are familiar with virtualization, I hope many of you have that background, where we have the option of executing hundreds of VMs or guest operating systems on a single platform, and those hundreds of VMs are managed by a super privileged software called VMM, Virtual Machine Monitor, or a hypervisor. And hypervisor acts as the software root of trust for this platform, where it has access to all the VMs, and it is also managing the underlying hardware resources to those hundreds of VMs. But from a security standpoint, what happens is I don't want to completely rely upon the hypervisor. If you understand the cloud usage, we have the cloud service providers like Amazon, Google, Microsoft, etc. They are the typical CSPs who are owning this hypervisor, and they will be responsible for running the VMs in a secure way. And to facilitate such usage model, Intel has two different technology offerings. One is called multi-key TME, which basically provides a capability to encrypt every single guest VM with its own private key and be able to isolate itself from other VMs. And we have other interesting technology called TDX, or Trust Domain Extension, where we will be able to isolate every single VM, which is called a TD or Trust Domain, from even the hypervisor. That means even if the hypervisor is compromised or attacked, I should be able to securely run my workload without being getting compromised. So that is the beauty of TDX, and we are going to discuss more detail on these technologies in coming slides. I hope you are all following what I am sharing, and maybe I can take one or two questions at this point just to see if you are understanding what I am describing, or it may be to more deeper into some of the technology, terminologies that we keep using at Intel. Any thoughts? Any comments? Okay, I assume so far so good. Let us move on to each of the technologies. So to get there, I want to introduce some terminologies. These are also very central to security in general. The first one is called Trusted Computing Base, or TCB. It is one of the important property of a TEE, Trusted Execution Environment, where it defines the list of entities or agents which are trusted for a given TEE. Now, I have some questions later in the form of quiz. That's why I want you to give attention to some of these terminologies. My intent, at least if you can take back these new terminologies and strengthen your security mindset and learning. Definitely, that is how I see success of my presentation today. So for the first technology we discussed TME, I told you that we have to trust all the applications, operating system and BIOS and hardware to really make this technology successful. Whereas for TME-MK, which is TME with multiple keys, basically we still have to trust the virtual machine or the guest OS, and also we have to trust the hypervisor, and even the host BIOS and hardware. They are also in trust boundary because they can have access to the key that we are using. Whereas with SGX, I told you that this has the minimal TCB or trust boundary, where I only trust the Ring 3 application in which my secure workload is running, and also a portion of hardware. Even the other privileged software on the system, they are not in my trust boundary and I don't trust them. The last technology is TDX, where we have a TD guest operating system, which includes both Ring 3 and Ring 0 applications. However, I need to trust only the TD guest OS
It
and
is
a portion of hardware. I don't even have to trust the
in
hypervisor. So this is how we will be able to distinguish the four technology offering from Intel based on the trust boundary.
application of machine learning
And one clarification with TME-MK,
level of the
based on how this technology used, we
firewall
can even keep the bias
university
outside of the TCP.
ML based,
Because if the VMM is able to manage
right?
and based on the usage, we can define the trust boundary accordingly.
I know.
Now let us go deep into each of these technologies. When I say deep, still a very high level, and I will give some useful links for each of these technologies. And if you are interested, definitely you can feel free to go and look at Intel website under each of the technology links to get more insights and understanding of the technology. These are the four technologies we are going to discuss. So the first one is total memory encryption with multi-key.
Definitely.
The primary objective of this technology is to prevent cold boot attacks, as I said in the beginning. And also, with multi-key DME, we will be able to offer secure isolation between the VMs because every VM can be encrypted with its own key.
See the
But only thing that key will be managed and accessible to VMM in case of MKTME. So in case of total memory encryption, what happens is the CPU, basically the memory controller within the CPU or SoC will have this memory encryption engine which is supported with the help of AES XTS, and that will be responsible for encrypting every data that goes out of the CPU to the system memory. And whenever the data is read from the application, it gets decrypted with the same key from the DME engine. That way, the DRAM content, which is nothing but a set of DIM devices, will always be encrypted. That's why even if an attacker get holds of your phone or a laptop, and if it is encrypted, and if they just dump the DRAM content, they will only see the ciphertext. They will never be able to see the plain text, and that's why whatever secure applications or sensitive data you have been using on your system, they will always be encrypted. That is the foremost usage and benefit of TME. Then why do we need multi-key DME? What is the difference? So here comes an interesting usage in a virtualization environment, right, where you have hundreds of virtual machines or guest operating systems that are all managed by the hypervisor or VMM, virtual machine monitor. And now you want to basically, let us say, two VMs are running in parallel and they are running their own secure workload. I want to make sure that those VMs are also encrypted in the DRAM because otherwise they will be prone to cold boot attacks. And I can also use a single key to encrypt all the VMs. but that is not secure enough because if one key, the key is compromised, all the guest OS or VMs are compromised. So to prevent such level of attack, MKTME offers another interesting no, extension to TME where I can use the physical address as a key ID to generate a VM specific key, and that key is basically again configured into the TME engine by the hypervisor, and that key is also at the page granularity. If you understand the virtualization or data, right, how the data is managed in the DRAM, it's all in the form of pages, as we know, right? It's all about managing the pages. The entire memory management unit only deals with pages. So as you see in this picture, every page, every page is associated with a single VM, and meaning it can be assigned to unique VM. And how I differentiate a page assigned to VM0 from VM2 is based on the key using which this page is encrypted. That means if VM0 is encrypted with key ID 0, that will be basically, it will be a property of this page where it says I am encrypted with key 0. Likewise, if a page encrypted with key 2 can belong to VM1, and that is how the hypervisor and the hardware will be able to isolate every VM from the other VM, and also it will encrypt every memory content that belongs to VM using its own unique key. So this is the extension of TME to offer multi-key support, and this is also very popular in data center usages. Where if I want to run my own workload and I want to isolate and encrypt it with my own key, we can leverage MKTME technology. And this link will give more details on the specification and architecture overview. Okay, now we are jumping into the other very important technology offering from Intel called Intel Trust Domain Extensions or TDX. So let me, in order to appreciate the value that TDX brings to table, we may have to understand virtualization little more in detail. So Intel CPUs also offer this feature called VMX or virtual machine extension, using which we can build virtualization environment. A virtualization is nothing but, as the keyword indicates, the operating systems or the VMs are not having direct access to the physical hardware. They are always virtualized. That means you have one super admin type of software called hypervisor or VMM, which is managing the hardware resources, and it will also assign those hardware resources to hundreds of VMs. That way, every VM may be assigned to a unique device, but that is also isolated from each other with the help of hypervisor. For example, maybe if you look at AWS server, log into their website today, you will be able to easily rent a VM, no, which may be running the latest, greatest software, and it may be running on latest CPU offerings from Intel, and you don't even have to buy anything. You can just rent it out such VMs for few hours for few cents. It is that cheap, and you can also run your workload remotely in those guest operating systems, based on your usage requirement. And that data center platform, if you look at compared to your laptop or PC platform, will contain the DRAM or the physical memory of size of hundreds of gigabytes or terabytes. It's huge, and you can have hundreds of guest operating systems or VMs, each half size maybe hundreds of gigabytes running on such cloud platform. And you can also have hundreds of thousands of PCIe devices being connected to the data center rack that may be shared by many platforms. So it's a very, very hardware rich environment where you will be able to leverage the hardware resources for your benefit. That is the beauty of virtualization.
Right.
And the key thing is in virtualization, basically, hypervisor is the root of trust and it has access to all the guest operating systems, including code and data. And typically, it is owned by CSP, as I said earlier. That's why you have to trust the hypervisor if you want to run your workload in a virtualization environment. Now comes an interesting question. What if the hypervisor turns malicious
Aku
or
unte bak.
gets
এখন একটা
attacked or becomes vulnerable? Right? Because in a cloud computing, as I said,
usual
we are running on some remote server. We don't know the
post
status of the platform unit, right? Either software, firmware, hardware, and it is not just possible to trust and run my secure workload.
security আপনি
So, in order to solve that problem, we introduced this technology called TDX or Trust Domain Extension,
রিপোর্টে আপনার
where even if the hypervisor turns malicious or gets vulnerable and attacked by a hacker,
each and every
my TDOS or the guest operating system where I am running my secure workload will still be isolated and made secure with the help of TDX. That is the main objective of trust domain extension.
তো ওটাও হ্যান্ডেল
Now let us go little more deeper into what is TDX and some of its key components,
ইয়ে
and you can also try to understand how
ওটা
from Intel side we are enabling this technology to offer isolation
নিউ
to TD or trust domains even from the hypervisor.
লাগবে না
So the primary objective of TDX is to remove VMM or the hypervisor and other system software from the TCP or trusted computing base of the tenant VM, which are now called TDs or trust domains.
তো হয়েছে
And we also want to offer runtime confidentiality and integrity to each of the TDOS running on that platform. That is the objective of TDX.
আগে একটা
And you may be wondering how do we do this?
ঠিক আছে
And architecturally, there are two important components we have introduced. First one is called a TDX module.
সার্ভার
As you see in the picture here, this is on the left hand side is the conventional virtualization where you have a host VMM or the hypervisor which is managing the
ইয়া
VMs and
এগুলো
now they are called legacy VMs. However, the VMM has access to all the code and data of these legacy VMs because it is the root of trust. And with TDX, I want to break that requirement
ইন্টেল
where I don't want the VMM to have access to these secure VMs. And those secure VMs are called trust
the
domains.
current state of
And what happens with Intel TDX is that we have introduced this new component called TDX module, which is an extension of VMM, is a software component which is running in completely isolation in such a way that even VMM will not be able to access or modify this software component. It is completely protected with the help of hardware security features. However, the TDX module still has to interface or interact with the host environment, and this is one of the security properties of a TEE we discussed. And how does the TDX module interact with the host VMM is through a well-defined host-side interface through a set of APIs.
ইন্টেল
So the VMM will make call to the Intel TDX module using these APIs, and Intel TDX module will basically verify the incoming API parameters to see what are the requests that is coming from VMM. One request can be to create a TDOS. So then TDX module will basically allocate the memory. Though VMM has allocated the memory, TDX module will verify and confirm that that memory allocated to a TD is secure, and then it will launch what is called a TDOS or the trust domain. And now, as you can see in the picture, the trust domain is fully isolated from the VMM. VMM will never be able to access to the data and code of the trust domain, and that is the security offering by TDX. Likewise, I don't want my TD to be even accessible to other TDs because even the other TDs can be malicious, right? If there are two users running a secure workload in a cloud platform, I want to make sure that those two users are also isolated from each other.
Motherboard.
And that guarantee is also offered with the help of TDX, where the TDX module will make sure that one TD is isolated from the other TD. And this is how we fulfill the security objective to isolate the VMM. And you may be wondering, oh, is it just a software based solution? Then how secure it is? Because if you provide any security capability using software, most of the time it's very easy to break as compared to a feature you can offer it with the help of hardware. So what we do in Intel architecture, we have introduced a new CPU mode called SEAM, which stands for Secure Arbitration Mode. So this is a new mode in the CPU in which the TDX module will be executing. That means when the CPU is running in the SEAM mode, it has the highest privilege on the platform. Whereas when it is running in VMM, it is running with lesser privilege, which means that whatever TDX module can access and manage, a VMM will not be able to do the same. That is how we, based on the hardware capability, we will bring privilege separation between TDX module and the VMM. So with the help of C mode and with the help of TDX module, we are able to protect the TDOS from the rest of the system, including the hypervisor. So now I can definitely trust and run my secure workload inside the TD. And TDX also provides the attestation capability where a TD application or a OS will be able to remotely attest itself to a third party server by providing all the platform level details. And if the remote server confirms that this platform is secure enough to execute, only then TDOS will start executing. So that is how TDX architecture looks like. From an adversary model, as I said, we want to keep the TCB or trust boundary with the very minimum number of agents. So from an attacker standpoint, lot of these software entities like unprivileged software, Ring Zero, or by startup code like BIOS or SMM, they can all be attackers. But Intel technology guarantees that even though those software components are malicious, our hardware architecture will guarantee the security to the trust domains. From a TCP standpoint, a TD will only trust the Intel hardware with TDX module and the CPU mode running in C mode. All other components running on the system, they can be untrusted or they can be malicious, but our TD will still be secure. So, looking at the key security objective of TDX, it is to offer confidentiality and integrity protection to trust domain. That is the primary objective number one. Secondly, we also introduce a new CPU mode called C mode, which runs with higher privilege. That way, we will be able to run the TD in a secure manner. And the third objective is to offer per domain memory integrity. Again, every TD can be encrypted with its own private key, and that key is also not available to hypervisor or VMM. So that way, we will be able to offer every TD or every domain via secure VM be able to protect itself for confidentiality and integrity. Threat model, attacker motivation, why someone wants to break TDX and what benefit they would get. So the primary motivation is to defeat the main security objective, which is to protect TD's confidentiality and integrity. Right? If an attacker is able to do that, then they will be able to easily access a secure workload running in a trust domain or a secure VM. So that is the primary motivation why an attacker wants to do that. And other motivations are with the introduction of new CPU mode, the attacker may also want to leverage the new privilege to cause other type of security issues on the system. And that is the motivation will be privilege escalation. And who are the potential attackers? The attackers could be a malicious host VMM, right? As we said, that itself can be a bad actor. and even the malicious guest TD. For example, as I said in shown in this picture,
Madam,
a TD cannot trust the other TD just like that. Where if I have running two users are running to secure workload, one user may become a bad actor for the other user. So that is why a TD can become malicious to other TD, and they may be able to try to compromise the other TD running on the system. And BIOS or SMM or even legacy VMs, they can also be attackers who are trying to get access to the TD secrets. So, in summary, TDX improves the confidentiality and integrity of trust domains against some forms of software and hardware based attacks. And we accomplish this by the combination of memory confidentiality and integrity and address translation using secure EPD. I'm not going into all these details, but this is how we establish the security of TD. And we also able to manage the CPU state confidentiality and integrity in a secure way, and we also offer remote attestation. So TDX as a technology is having a strong roadmap from Intel side. In the very basic architecture, what we introduced with our first generation product, it is called TDX 1.0, and we have released another intermediate TDX roadmap or technology offering called TDX 1.5, which provides some useful features like TD migration. In data center, what happens is if I am running my workload and
wait.
suddenly a platform becomes busy where it has multiple or hundreds of workload running parallel, the CSP wants to migrate my workload from one busy platform to a lesser busy platform, and they want to do it live, which means that my execution of workload should not be compromised or it should not go through any halt. So we will be able to migrate the workload from one platform to the other easily live, and that feature is called TD live migration. And I also mentioned about secure IO, which is also an important property of TEE. In the next generation of Intel TDX, we are offering something called Intel TDX Connect, which basically provides a way to allocate different PCIe devices to TD operating system in a secure manner. That way, we can also do trusted IO transactions. And this link has all the details of TDX architecture. So coming to use cases, TDX primarily can be used in data security and IP protection, right? If you are, that is the primary motivation where you want to run some security sensitive workload or maybe some intellectual property that you are really trying to protect, you can leverage TDX to run it in the form of TDOS and be able to protect it. And data sovereignty and control, this is also another major usage where in the global usage model, when you are running your workload in the cloud environment, the data management rules and privacy requirements can change from one country to the other. And TDX can leverage the policy driven approach to fulfill the requirements based on the country in which we are managing the data. The privacy and compliance, of course, is also very important, and we will be able to protect the privacy of the data by making sure that the confidentiality and integrity is maintained. And the most important emerging usage is called confidential AI. As we are in the artificial intelligence era, we are only talking about AI workloads maybe going forward. And now I want to run my AI workload again in a secure manner. How
আমি
do I do that?
full
TDX can be a classic example where you can run entire your model, data model, right? Algorithm, whatever intellectual property associated with it, whatever security capability it is offering, they all can be run within a TDOS in a secure manner so that they are guaranteed to be protected at all
tips
times.
on it ওটা কি
So that is the beauty of confidential AI, and TDX can be one major vehicle to accomplish it. So these links so basically provide very good links to the lot of specification of no Intel TDX.
Start to develop.
And I also have given some links to the security publications where we jointly did research with Google Scholars last year. So we have published some very interesting research report out of it. You can also take a look at this. So after this, so Intel Software Guard extension. So we talked enough about TDX. Now let us go and understand what is SGX or Intel Software Guard extension. Software guard extension is nothing but a set of new CPU instruction enabling application to protect critical secrets, which I briefly introduced in the beginning. So it provides protection against software attacks and some hardware attacks. And also it provides hardware-based memory encryption that isolates the specific application code and data, and also it enables the user level applications, they are called as GX applications or enclaves, to be protected from processes running with higher privilege levels. As I said, even the operating system running with ring zero privilege will not be able to access any data that belongs to a ring 3 application. That is the beauty of SGX. And it also offers hardware assisted remote attestation to measure and verify the valid code and data signature. This is another important property of TEE to offer remote attestation capability. From a high level security objective, SGX provides the protection, the memory from loss of confidentiality and integrity type of attacks, and also it provides protection against replay attacks. That's why we have anti-replay protection, and this is offered both in the hardware and software manner. And the link to HGX technology papers are all available in this link.
Patient monitoring.
Now, I think only caveat is I'm not able to get to the presentation mode. Let me do that and see if you can see my screen.
ওখানে হয়তো SOP দেবে।
Are you able to see my screen, the presentation mode?
No, Raju, we
আমার টাইম
couldn't.
আছে আপনাদের।
Okay,
Or maybe
yeah.
it may be only selected to the specific screen or the whole screen
স্টার্ট করে
that
দিয়েছি।
you share.
No, yeah, I shared the whole screen. The specific screen did not work.
Okay, then
Yeah,
if still it
some.
is not
পেপারগুলো
showing,
I
so it
see.
will continue as it is.
Right, right. Okay. So main thing I want you to give attention about SGX is to appreciate the reduced attack surface. For example, in a conventional operating system and virtualization environment,
তো ওই 2 দিন।
right, you have VMM, OS, and the application. They are all the yellow no dotted lines show that they are all need to be secure in order to secure my application. But with SGX, it is only this red color dotted box, right? A portion of hardware and a portion of or a ring 3 application. These are the only two components I have to trust.
হলো
Other components, if they are compromised, we will still be able to protect my ring 3 application code and data.
আপনি রেগুলার অ্যাট লিস্ট
So
উইকলি
that
বা
is the primary objective of SGX to minimize the attack surface.
দেওয়ার
Application gains the ability to define its own secrets, and that's why we have the smallest attack surface.
দাওদা থেকে
And other advantage is having a very familiar development and debug environment, because this technology, just like TDX, we are offering on the mainstream Xeon CPUs,
পেন্ডিং এ
which
রাখা
are very performance oriented. So your secure applications will also be very performance savvy, and they will get all the benefits what a main core Xeon CPU can offer.
তো
So that's why it's another advantage. And in terms of scalability, SGX was offered on our
তাহলে
laptop, desktop, and even device Atom CPUs. And starting with Ice Lake server CPU in Intel,
আমার
we started supporting SGX on servers.
মনে হয় আমারও মনে হচ্ছে
I think it's a bit challenging to describe this without a proper build of the slide, but maybe I will just read through it. Right? Basically, in the we want to show how SGX can protect the SGX application from against software attack.
quite a
That
way.
means, see, we have basically when you build a SGX application, it comes with two parts. One is called trusted portion, the other one is called untrusted part. And Intel also provides SDK or software development kit. So using which we will be able to run the secure sensitive workload inside the trusted portion of the app.
মানে দুটো
However, when the
মানে যে হ্যাঁ
application gets launched, it starts with untrusted world. And now when I want to execute secure workload, I will do some
বর্তমান কারেন্ট
calls from a untrusted portion to the trusted portion using the API supported by SGX. And when we enter into the trusted application, the application will be able to execute some secure workload. And as you see here, I'm processing some social security number related workload. And now, as you can see, the secure application or SGX application will be able to see my SSN details in clear because it has access to the code and data.
সার্কি রে
But once I exit from my secure world,
সার্কি রিভিউ
the untrusted portion or even other software running on the platform, if they try to access the SGX memory, they only see the ciphertext. They will never be able to see my secure data in clear.
বারবার
That is how SGX offers protection against software based attacks.
মিষ্টি আছে আমি শুনছি বৃষ্টি আছে
For hardware based attack, this is another classic example where if you are processing your data in the CPU, maybe you are processing some credit card details, some application, right? However, we have been saying that when you store or read the DRAM or the system memory, it always gets encrypted and decrypted by the hardware. So because of that property, even if you have some snooping agent or interposer or any hardware attack capable devices,
আরে
they will only be able to see the encrypted data or ciphertext and they will never see the clear text.
কেস নেই
So that is how SGX can also protect the application from some hardware based attacks.
রিপ্লাই দিচ্ছে না যে
So, from a cloud service provider usage, SGX has been adopted by Microsoft Azure as one of the primary vehicles of offering confidential computing, where it optimizes for confidentiality at the application level, lift and shift the existing application into secure enclave, use confidential nodes like containers supported by Azure Kubernetes Service. So, this is how SGX has been adopted in cloud usage, and IBM also has this cloud data sheet, which is also leveraging SGX to provide data security. So, in a quick summary of SGX, basically it reduces the attack surface around your data to unlock new opportunities, right? Because it creates the smallest trust boundary available and it protects data everywhere it may be exposed because it has the Ring 3 level application can protect itself from any privileged software in the system. That's why it is highly protected. And it also strengthens the enclave trust and boosts the user confidence because of the attestation capability, where SGX can also help the application to attest itself to a remote server to check whether a given platform is trustworthy or not. So that way, SGX fulfills all the properties of TEE.
এটা হচ্ছে আদা
So these are some capability you gain with SGX, confidential AI and analytics. Again, this is where emerging usage with the AI era, and SGX can also be a great vehicle to fulfill that. Only thing in case of TDX, we are running the entire secure workload in the form of a guest operating system. Whereas with SGX, I can even restrict that to run as a Ring 3 application. So that way, SGX can complement the usage of TDX.
মানে এই
And sovereign data and compliance is another usage model, just like SGX, and more confidential collaboration, right? Because maybe if you are running across the geos, or even within an organization, you are running different workloads, you can establish the confidential collaboration in the cryptographic manner so that you know what workload is running on my system and whether I can trust the other workload running on my system or not. So SGX can provide that more confident collaboration among the application usages. With that, I think I have come to end of my presentation. I can take questions, but meanwhile, maybe I will start with some quick questions, which are also maybe able to check the level of understanding you might have accomplished out of this presentation. Maybe I would like you to just speak out the answer, and then I can take any specific question from the audience. So, what is TEE stands for? What is the answer?
Trusted execution being B balloon. Balloon na.
Trusted execution environment.
That's right. Let us see. We have okay. So the next question is, which security property of TEE guarantees the legitimacy of a TEE environment?
Here, beta.
Any thoughts?
No idea. Balloon kiba.
We talked about three properties of a TEE, right? Where it should isolate itself from the host environment and it should be able to talk to devices securely. And third one, it's supposed to talk to a remote server. So which of this feature will help to determine a platform is trustworthy or legitimate? Okay, is the attestation, right? Because attestation is the process where we will be able to determine whether a given platform is trustworthy or not.
TCB stands for
Number three, what is TCP? What does it stand for? Any guesses? What do you, we talked about it a lot.
trusted computing.
It's trusted computing base. Okay. Which one of these technologies has relatively lower TCP?
Inshallah.
Any guesses?
Uh,
It's okay, you can just say, you don't need to be right. Even you can guess it now.
LinkedIn. Associate teacher.
So in chat, Siddharth saying it's option C, SGX.
Oh, okay. Someone is answering through the chat.
Larger teacher means larger. Hey,
That's good. Yeah, four number four answer is C.
yes,
What is answer for number five? Larger the TCP means
larger the AKS
can you guess those two words?
attack the secure
Anybody is answering?
attack
Okay, it is attack surface
attack.
because if you have to trust more entities on the platform, your attack surface will also grow. Okay, number six. I hope you guys provide answer to this. Confidential computing offers data protection. What is the answer?
Siddharth is saying answer A, B, and C.
Oh, okay. No, the correct answer is B. Because if you remember, I told you in the beginning, confidential computing offers data protection while it is in DRAM or while it is in under use, whereas protection at rest and transit are offered through other means. Okay, This is another question. Cold boot attack prevention for the entire DRAM is the primary objective of which technology? Any guesses is fine. Don't have to be right always. You
Again, give back that.
can just speak out. I know a lot of you are hearing many of these things for the first time, and my objective was to bring the awareness and introduction to these technologies, which are very complex in nature, right? Unless you have a vested interest to get into the security domain, it may be very initially definitely be difficult to gather and understand what we discuss. But however, as I said, this is certainly one of the emerging markets where, from industry standpoint, academia standpoint, security is becoming very critical. So, understanding these terminologies will definitely benefit you. So, the answer is B, where total memory encryption will help to prevent cold boot attack by encrypting the entire DRAM. I hope there was. Okay. I have only two more questions. I think this I have to fix. This is number 9. TDX technology protects a TD trust domain from what? A malicious VMM, a malicious VM, or both? What is the answer? You guys can just guess and then.
Malicious VM. Uh, Sorry, both actually. Malicious VMM.
Good, very good. Yeah, exactly, right? Because we want to protect from both hypervisor and VM. That is the objective of TDX. Okay, this is my last question. What does SGX stands for?
Security guard extension.
A or B?
Software guard extension. Software ಆಗಿದ್ದಾರೆ ಅಲ್ಲ
No answer?
no answer. October 7th.
Software guard extensions.
Good. Yeah. All right. So with that, I have come to end of my presentation. Thank you. And if you have any questions, I can take.
Yes,
So now I request the audience, if any one of you have any question, you can ask now. You can unmute yourself and type it in the chat box.
Canada all good.
Anything in general is also fine, right? If you want to know something about what we are doing in this space or any general questions, not necessarily to related to only this topic we discussed, it's okay. If you are interested in security, you have all the opportunities to ask.
Yeah. Hello.
Yeah.
Yeah. So Kunto here once again. Thank you so much for your talk. Sorry, actually, I'm joining from mobile because I'm busy in some personal family matters. So actually, I'm not in lab right now.
Hmm.
Anyway, so no, I don't have any question on your talk, but I think in the email thread it was mentioned that there is something called Intel Sleep Fellowship. It would be talked about. So is like can you just like enlighten us on that and one more thing actually generic way I would like to ask you in like it will benefit all research scholar community as well as generic students like how all like if you can if you know actually that how all Intel like what are Intel's opportunities to like career opportunities to research scholars like once someone has done their PhD, so how can they join Intel and like is there any like process formal process or link or like do we send our CVs or like if you can shed some light on that.
I think, yeah, I can take the second question later. For the first one about Intel
Like
lead
you
program,
can also guide us to the correct email or correct
yeah.
branch who is handling that matter, and we'll just disburse this information and the scholar community that anyone interested can just email or ask that. That is also fine. Like if you don't have any specific like answers.
Yeah, for that specifically, I'm sure no, you can also reach out through the professors and through collaboration. Intel has joint research collaboration with professors in IIT Kharagpur. That can be one very good way to approach. The other approach is also on Intel website. There will be a lot of job recs and openings that will be mentioned, using which you can also approach. The other one is through collaboration through Intel Unnati, Intel Lead Program, and others, where we have been collaborating with academia for many objectives. And certainly, we are also looking for skilled professionals in the technology area that Intel is working on, and so the research is one major objective and area of funding in Intel. It could be in different areas, right? And for specifically for research scholars, I'm sure there will be lots of opportunities in the areas of hardware, firmware, software, platform, of course, AI, whatnot.
Yeah.
And
Thank you
the
for
Sure. And on the Interlead program, maybe I will ask Ramaya, who is on the call, to discuss present about it.
Yeah, yes, Raju. So to give a brief about exactly what you asked is uh, the related to the full-time job, as Raju said, like you can through LinkedIn or the Workday, you can see what are the job posts are available right now. So that's a one option. So for the first question which you asked for research collaborations as well, uh, uh, kind of if you're into the fellowship or something. So it's a best opportunity. What I would like to say is that in under Interlead, it's a program called the Fellowship, Interlead Fellowship Program. So where we will call for papers and we have specific titles and which our business units are interested to collaborate uh, on the research topics which they are interested. Uh, that areas through professors, through the internal supervisors, the students who are in uh, PhD or MEM, that role of research scholars can play. Through the multiple screening, once they shortlisted, then they have opportunity to work on the same research project along with our Intel experts through the fellowship program, maybe it's a 1 year or case to case. Okay. After that, it will be lead to the employment opportunity and internship. So that's the objective of that particular fellowship program. So last year also we opened it, and for this year also we are expecting to do it in mid of this year. Probably you'll get the update through the point of contact in correct through professors. And you can also be in connect with me. So I'm also part of a interlead fellowship program. So I'll also keep you posted if it is open.
Con, con, con.
Thank you,
Hope I
Ramaya.
keep it right. Yeah.
Yeah. So, any other questions?
Hi, Raju. I have one question. First of all, thank you for the talk. So,
Sure.
the question is the mostly you define all the three technologies is based on encryption decryption process, right? So, just
Mhm.
curious, like how costly it is based on the performance, because we know like encryption, the costly costly operation. So,
Sure.
how it's impacting on the performance?
Yeah, it's a very good question, and that has always been a challenge, right? Performance versus security, there is always some overhead. So to counter that problem, based on the technology improvements and all these encryption, decryption, they are all built into the hardware. So that way we have a lot more performance benefit on Intel hardware architecture. But even otherwise, it depends on the type of encryption schemes we use and the hardware capability we have. I would say it is in maybe in single digit performance impact compared to a secure versus non-secure workload.
I see. Okay. And one more question is like the encryption is done with it's a symmetric one, right? AES, XTS. So is the
Yes.
key symmetric or like how it is generated? And
So the key is basically these keys are no session-wise keys. On every single boot. The hardware and firmware, secure hardware, firmware will generate these keys, and they will be programmed into the hardware and locked. So they remain same for the entire boot flow. Once you do a reboot or a cold boot, the keys will have to be configured again.
I
And in a
see.
data center, most of the time the servers will never be booted for months. So
Hmm.
that way, you don't have to reconfigure, reboot the system often.
So it happens only on cold boot paths, right?
Correct. That's correct.
Okay. I see. I see. Okay. Thank you.
Sure. Good
So
question.
is
Any
there
other
anyone else?
questions?
So I think so, sir. There is no more question. So I would like to ask one question from my end.
Mhm.
So it is not in depth, like it is a bit generic. So like as you were telling about AI, so can you just enlighten on the application of AI with respect to security you have talked about, or like Intel is working, like if it is possible. So can you just enlighten us in this domain?
Sure. See, the new trend or the new buzzword is AI for security and security for AI, right? The artificial intelligence
Mhm.
is nothing but a new technique of programmability or programming things, right? It's a technique or a method to basically accelerate the programming and use different techniques to do things faster and more. AI is basically, had two major components, right? Inference and training. And these are nothing but some models, algorithms using which we can implement these techniques. And
Mhm.
security can be applied in two ways, right? One is if you want to run such AI workload where maybe you are computing some workload with some high security data using AI techniques, that model itself need to be protected, right? You cannot run them in your normal workload because if it falls in the prey of an attacker, your workload will be compromised. And that is why we have technology like SGX or TDX, where you can run your AI workload in a isolation, in a protected manner. That way, it is guaranteed by the hardware to be protected, and that is called security for AI. Means we are protecting or offering security to AI workload. The other aspect of AI is AI for security. For example, if you see today, right, attackers or researchers are using some techniques to compromise software, hardware, or firmware security. They have tools, they have some techniques, they use some hardware based attacks, whatnot. With the emergence of AI, all those attacks can be now made faster, and maybe they can become really targeted. That way, it makes the attacker life also easy. As a hacker, as a researcher, my role, I am looking for some emerging AI models or techniques using which I can try to break some of the security claims of products that we develop in house. Likewise, external researchers can also abuse the AI techniques to target and create new attack methods. That is called AI for security. That means we can also use your AI to break. Other thing, we can also use AI to protect. Means we can also use AI technique to make things more secure because you have better algorithms and techniques. using which you can learn and train the engine in such a way that if some attack happens once, the system can learn itself to prevent from such attacks. Next time when it happens, it will be able to detect and just stop that attack from happening. So there are advantages, right? Applying AI for security. Likewise, we also have to protect AI models by using security technologies. And confidential AI is one classic example to meet that requirement. I hope
Thank you,
this
sir.
answers
Thank
the
you
question.
so yeah. Thank you so much, sir.
Sure.
So
Right.
anyone else? I don't think others are having any questions. Let me check the chat box once again. No. So I request all participants to kindly fill up the attendance form before you leave. And now I'm going just a second. I will be sharing my screen.
Screenshot and
Thank you so much, sir, for this wonderful talk once again, and to audience as well for spending your valuable time for attending this talk. So now, on behalf of the IEEE CSSPC, I would like to present a virtual token of appreciation. It is a virtual memento that we are presenting to you, sir. And now I
Thank
would
you.
request, thank you, sir. And now I would request the audience, if possible, to turn on your camera so that we can take a group photo.
Yeah, guys, let us do it as we have spent an hour on the evening on a Friday.
done. Done.
Okay. Thank you
All right.
everyone for sharing, for being present over here. So here we conclude our session. Thank you everyone and thank you sir for this wonderful talk once again. Bye.
Bye. Thank you all. Bye.